Welcome friends to the second session on gear trains. In this session, we are looking at how to solve problems related to epicyclic gear trains. We'll be finding velocities of various gears which make up the gear train. So let us get started with the very first problem that we have. It's a very simple problem. The question says that an epicyclic gear train consists of three gears A, B and C as shown in figure. So this gear over here, which I am showing by my mouse pointer, this is gear A. This blue colored gear is gear B, and this red colored gear over here is gear C. Now, gear A has 72 internal teeth and gear C has 32 external teeth, which means the number of teeth on this internal gear A is 72 and the number of teeth on the external teeth on this gear, that is gear C, is 32. So I am making note of this data over here. So number of teeth on gear A is 72, number of teeth on gear C is 32. It is said in the next line that gear B meshes with both gears A and C and it is carried on an arm EF, which is rotating about the center of A with a speed of 18 rpm. So this gear B is in mesh with gear A. It is also in mesh with gear C and it is carried by an arm, this arm EF, about the center of gear A. Please note over here that gear A, gear C, they have coincident centers at this point E over here. They have also said that this arm EF is rotating with a speed of 18 rpm. So I am making a note over here of the given data. Speed of arm is 18 rpm. If the gear A is fixed, then they want us to find out the velocities or the speed of rotations of gears B and C. That is, if this gear A is fixed, what is the speed with which gear B and gear C is rotating? That is what we need to find out in this particular sum that we have. So the given data over here is gear A is fixed, which means speed of rotation of gear A is 0. So n suffix A is 0. And we need to find what are the speeds of gears B and C. So let us get started with solving this problem. In the next slide, the data that was there in the previous slide, I have made a note of it. TA, number of teeth on gear A is 72, number of teeth on gear C is 32. The speed of arm is 18 rpm. Speed of gear A, which is this outer gear A, since it is fixed, it is 0. We need to find the speeds of gears B and gear C. Now, this table over here that you see is a very generalized table, and this particular table is going to be used throughout all sums that we are going to solve related to epicyclic gear trains. Now, the characteristics of this table, the number of rows that you see in this table, there will be 4 rows, each corresponding to each step that is required to solve the sum. For step number 1, we have 1 row, step number 2, we have another row, step number 3, we have 1 more row, and for step number 4, we have the last row. And the number of active columns over here, that is this column, this third column, and this fourth column over here. The number of active columns in this particular table will be equal to the number of elements which make up the gear train. So in this gear train that you see in figure, gear A is one element, gear C is a second element, arm EF that you see is a third element, and this gear B that you see over here, this is the fourth element. So there are 4 elements, therefore 4 active columns in the table, and we need 4 steps to solve this sum. That is why there are 4 rows over here. Please note, all tables that you are going to draw for solving sums on epicyclic gear trains will consist only of 4 rows. But the number of active columns that will be there in each table will vary according to the number of active elements that are present in the sum that will be given to you. And step number 1 is, so before going that, let us complete this heading over here. So this is step number, conditions of motion, and over here we have arm. So in all table, the first column will necessarily be your arm itself. What is the name of arm? Arm is EF. So I will make a note here, that is arm EF for this sum. Now we have 3 gears. You can start with any gear that you see. That is, you can start with gear A, you can start with gear C, you can also start with gear B. There is no fixed restriction with which gear you used to start. But in generally what we can do is we can start with the gear that is there at the center. So I will start over here gear C. Now once I start with gear C, the next column that is corresponding to gear C should be that gear which is in mesh with gear C. Now for gear C, gear B is in mesh with gear C. So this column I will write, this is for gear B. Now with gear B, which gear is in mesh? It is this internal gear that you see. This gear A is in mesh with gear B. So over here I will write, this is for gear A. Now what are the various steps that you are going to use to solve this sum? So the very first step is arm is fixed and gear rotates through one revolution anti-clockwise. Now which gear rotates? The first gear that you have mentioned over here. So this is C. So I will write here, arm fixed, gear C rotates through one revolution anti-clockwise. Now since arm is fixed, which means speed of rotation of arm will therefore be 0. Please note, this is no way related to the question. In the question it is said that arm is revolving or rotating with the speed of 18 rpm, but currently we are not focusing on that. Currently we are focusing on completing this particular table that is there in front of us, and for this table of all sums, the very first step will be fixing the arm. So arm fixed, gear C rotates through one revolution anti-clockwise. Now if gear C is rotating through one revolution anti-clockwise, what will be the speed of gear C? Of course it will be 1. Now gear B is in mesh with gear C. If gear C is rotating with one revolution anti-clockwise, what will be the speed with which gear B is rotating? In general, we know when two gears are in mesh, then the velocity ratio, say for example gear 1 and gear 2 are in mesh in general, then the velocity ratio N2 by N1 is equal to the ratio of number of teeth on gear 1 to number of teeth on gear 2. Therefore, this N2 that you see over here, this N2 will be equal to N1 into T1 by T2. So using this concept over here, velocity of gear B, that is NB will be equal to speed of gear 1, which is nothing but in this case NC into T1 by T2. So here it will be number of teeth on gear C to number of teeth on gear B. Now since NC, that is the speed of rotation of gear C, is 1 currently in this table, so I will just remove NC because NC is 1. Now if gear B is rotating with the speed of TC by TB, what is the speed with which gear A is rotating? Using the same concept over here, when two gears N2 and N1 are in mesh, then N2 will be equal to N1 into T1 by T2. So over here in this case, speed of gear A, that is NA, this will be equal to speed of gear B, that is NB into number of teeth into the ratio of the number of teeth on B by number of teeth on gear C. From where are we getting this? We are getting it from here. N2 is equal to N1 into T1 by T2. Now, how much is NB? NB is speed of rotation of gear B. So, NB is equal to, oh, I made a mistake over here. So, this should be TC by TA. Now, it is correct. NA is equal to NB into TB by TA. Now, how much is NB? NB is equal to TC by TB. So I am taking this from here and I will replace NB with this particular value. Now if you note over here, in this term TB is in the denominator and in this term over here TB is in the numerator. So TB and this TB we can cancel them out. So I will just remove this. This is what we had. So this TB which is the denominator and this TB which is the numerator will cancel out each other and ultimately we will be left with NA is equal to TC by TA. So this NA now is not, it simply means speed of gear A. So I will remove this also from here. Now we need to take attention, we need to pay attention to the signs that has to be attached over here. Now here it is said gear C is rotating through one revolution anti-clockwise. We will treat all anti-clockwise rotation as positive. So I will add a plus over here to simply denote that it is rotating in the anti-clockwise direction. Now if you pay attention over here, if gear C is rotating in the anti-clockwise direction, then gear B, which is in mesh with gear C, it will rotate in clockwise direction, which means it is rotating opposite to the direction of gear C. So to show that it is rotating in clockwise direction, I will make use of a minus sign over here. Now gear A is in mesh with gear B. Since gear A is in mesh with gear B, and since they are meshing internally, gear A will also rotate in the same direction in which gear B is rotating. Here between NB and NC we had external meshing, but between gears B and C we had an external meshing, but between gears B and A we have internal meshing. When two gears are meshing internally, the speed of rotation of both gears will be same. So therefore, since B is rotating in the anti-clockwise direction, A will also rotate in the clockwise direction. So this completes our first step over here. Now the next steps are very simple. So the next step is arm fixed gear. Which gear? The gear that we took in step 1. That is gear C is rotating through X revolutions anti-clockwise. In step 1, we assumed that gear was rotating by 1 revolution anti-clockwise. Now we are assuming gear C is not rotating by 1 but is rotating by X revolutions anti-clockwise. So since arm is fixed, this will be 0 itself. Over here we will be having, instead of 1, since it is rotating by X revolutions anti-clockwise, this will be X. Now in this, please note here, speed of rotation of gear C was 1, but now speed of rotation of gear C is X. So this will be X into Tc by Tb. And since gear B is rotating in the anti-clockwise direction, I will use a minus sign. Now over here, the speed of rotation of gear B is now X times greater. So this final velocity, this will also be X into Tc by Ta. Done. Now this minus clockwise, I will just add a minus sign over here. This minus sign I am adding over here to indicate that gear A is rotating in the clockwise fashion. Now if there is any confusion related to what we did, please note just do one thing. That is, in step number 2, simply multiply all elements of all data in step 1 by X. So this will be X into 0, which is 0. This will be X into 1, which is X. This will be X into Tc by Tb, therefore X times Tc by Tb, and this here, this is X times Tc by Ta. So I can rearrange this by, I can simply say multiply all elements by X. So this is simple now. So multiply all data in step 1 by X. Now next step is simply adding plus Y revolution to all elements. So we do nothing, we in all column that is here, we just keep on adding plus Y like this. So this is plus Y and this is plus Y. And the last step, that is step number 4. In step number 4, we are taking the total motion. Total motion मतलब ये जो step 2 और step 3 के जो data है उसका we need to add them together. Total motion step 2 plus step 3. So in this case, this will be plus Y plus 0, which will be plus Y itself. Here it will be plus Y plus X, which is simply Y plus X. So I will just remove this ply because it is same. Now over here, what will be plus Y plus of minus X Tc by Tb of simply adding. So this will be Y minus X Tc by Tb. And here this will be Y minus X Tc by Ta. So that's it, friends. We will stop here. In the next video, we'll continue from this forward. Here we have currently completed the tabulating of the data that is required to solve this sum. And in the next steps, we will find what is the values of X and Y. Thank you.